Hello everyone. So in our previous video, we actually discussed about that how we can represent a hash node in a hash table. So in this video, we will see that how we can implement a hash table via separate chaining collision resolution technique. So here in order to implement a hash table, I will be creating few videos which will be in series. So you can consider it as a part 1 of how to implement a hash table. But before we start, in case if you are new to my channel, then please subscribe to my channel so that you never miss any update. So friends, in order to implement a hash table, we will first look into some of the terminology which we will be using frequently in upcoming videos to understand different parts of hash table. So here, as we already discussed, that hash table is nothing but a generalized form of an array. Now let's say if we take the example of this array whose length is 10 and having index value from 0 to 9. So when implementing a hash table via separate chaining collision resolution technique, we discussed that we actually use the hash node. So here, in order to store key value pair, we simply take this as an array of hash nodes. So to this array, we simply call it as buckets and we denote it something like this, that each container at a particular index is termed as bucket, and this array basically stores hash nodes which has key value pair and a reference to the next hash node. And here we will also create a variable which would be number of buckets. So this number of buckets is nothing but the length of buckets array, which is also called as capacity of hash table. So for example, if we want to store a key value pair, let's say if our key is of integer type having value as 10 and a value of string type which takes in a value as James, and if we want to store at 0th index, what we do is the 0th index bucket simply points to a hash node storing key value and has a reference to next node. So currently if there is only one element, then the next node will point to null. Similarly, let's say at index 1 if we want to store a key value, so it would look something like this. So here you can see that the way we are storing this key value pair is via hash function, which we already discussed in our previous video and which we will be discussing in our upcoming videos also. That here you can see the key is 10 and here let's say if we take the hash function as key mod the number of buckets, which is also the length of this array, then we get 10 modulus 10, which will give us a remainder 0, and whatever we get from the hash function, it is nothing but our index. So at the 0th index you can see that we have stored a key value pair like this, and similarly at 5th index we are storing a key 5 with a value as John. So here 5 when divided by 10 gives remainder as 5 only. So at 5th index we are storing a key as 5 and we usually term it as hash node, which we have already discussed. Now let's say if we want to store a key of 105. So when we divide 105 by 10, we get remainder as 5, which would be the value returned by our hash function. So if we go at index 5, we will see that there is already a value. So there is a collision. So in order to resolve this collision, we are taking help of hash nodes, because here you can see that the third data member is nothing but a reference to the next hash node. So here we can use the next reference to store this key value pair, which also corresponds to 5th index. So here when we store this key value pair in form of a linked list, the first element is simply treated as head, and this linked list is also termed as chains because we are discussing separate chaining collision resolution technique, and which is being implemented via chains. So here when a collision is encountered, the key value pairs are stored in a form of chain, and this chain can be the way you want to implement. You can simply add the newly inserted node at the end or at the beginning, or you can insert in a sorted form. like based on the keys, that 5 comes before, 105 comes later, and then 205, 305, something like that. So you can insert multiple key value pair, which is also called as hash node, in a way which you want. And similarly, we can store other values like this. Also friends, here you can see that length of this array is 10, which is also a value stored by number of buckets, and which is also called as capacity of our hash table. But here you can see that this hash table currently has 1, 2, 3, 4, 5 and 6 hash nodes. So the size of the hash table is 6 because it has hold 6 key value pairs, and the capacity is of 10. So this is the difference between the capacity and size. So when we talk about size, you can think of it the number of key value pairs inside a hash table. And when we talk about capacity, number of buckets or length of buckets, we are simply talking about the array length. So friend, these are the few terminologies which are being associated with hash table. So here, when we implement a hash table, you can see that we have 3 members here. One is the buckets array, which is of type hash node. The second value is number of buckets, which is also the capacity of our hash table. And the third variable is size, which is the number of key value pairs being stored in a hash table. So here you can see that hash table has a constructor which takes in a capacity. So when we create an object of hash table, we need to provide that what's the capacity of our hash table. It means we are providing that how many buckets the hash table will have. And here you can see that internally our hash table is using hash node class. So which we already discussed, that it has a key and a value and a reference to the next hash node. So here you can see that we are taking key as integer and value as string. So this can be any generic type. So for the understanding and demonstration, I will be using the key as integer and the value as string. So basically most of the things remain same when we take any generic type of key and value. So here after taking key as integer and value as string, and the third member is a reference to the next hash node, which help us in storing the key value pair in a chain when the collision occurs. So here what we do is, at the start we simply call and create an instance of hash table, and let's say we pass capacity of 10 to our hash table. So it looks something like this, that capacity value is 10, and in the hash table constructor what we do is we assign the capacity to number of buckets. So it becomes 10, and then we create an array of hash node and we provide the capacity. So it looks something like this, that internal data structure is array of type hash node. It is being termed as buckets, and each compartment here you can see is a bucket which holds the hash nodes in a form of a chain. So here when we create this array, at the start every index or bucket points to null because there are no hash nodes currently into this array of hash nodes. So at the start size remains 0 because we currently don't have any key value pairs inside this hash table. So size is 0. So friends, in this video we saw an initial implementation of a hash table via separate chaining collision resolution technique. In our upcoming videos, we will see that this hash table has many operations where we put a key value pair, we remove a key value pair, and we can get a value based on a key. And there are many other operations which we will be looking into our upcoming videos. So this is just a basic and initial implementation of a hash table. So now let's go to our IntelliJ IDE and we'll simply code this part into the IDE. I hope you have find this information useful. And in case if you find this information useful, then please like this video. And if you are new to my channel, then please subscribe to my channel so that you never miss any update. Thanks, have a nice day.